explosion because someone was smoking when they weren't supposed to be, and it blew up. It was full of grain. It wasn't full of anything you would think would be that would work as an ideal fuel. But when churned up and there's enough surface area, bad things can happen. So very, very important to note. Next thing covers the last type of fuel that we've yet to cover, because we have solid fuels, liquid fuels, and gaseous fuels, right? So the gas fuel we're going to use is a fuel that you've all used, I'm sure, common for heating inside the house, common for cooking in cars, and you also make it. It is what? Gas. Methane, natural gas, or fart. Well, you can call it what you will. So natural gas is what we're going to use, and it's about 90% methane. Now methane is a very special gas. It is lighter than air. It floats. But the first thing I want to point out, how many of you can see this? How many of you saw gas come out? How many saw gas? Excellent! We're all sane today. That's right, you can't see it. But what sense do you have to sense that it's present? Smell. You can hear it. Very good. But you can smell it as well. And you can smell it because the gas company puts something called mercaptan into the gas. And when it puts this mercaptan in, it gives it a rotten egg or a rotten smell type, rotten egg, rotten cabbage type smell. That comes out and you smell it. However, when you burn the gas, you also burn the mercaptan, no smell. So a very, very neat little added feature. Not to mention that methane is an incredible greenhouse gas, and cows are a very significant contributor to the problem. So you can see it's dripping over right now onto the floor, and that's fine. The surface area to volume ratio of the bubbles is not quite there yet, so it's going to spill over. But once it gets to an appropriate size, it's going to start to float. It's going to grow like Marge Simpson's hair, and then it's going to break off and start to float up. Air has a molecular weight of 29. This has a molecular weight of 16. So it's going to float up. It's almost half. So up it goes. The Marge Simpson's hair, break up. You're going to have lots of surface area because it's a gas. You have your heat source and oxygen. And they all come together to form a very pretty full fire. Whee! So we're going to get that to go again because that was exciting. Here we go. Come on. This is good. These are big. Higher? Like that? You want to try and feel the heat? Alright, let's do it. There we go. So you can see it burns very nicely. It's very quiet and also burns very well and very quickly. And again, it has to do with this surface area aspect of it being very spread out. You felt warm? Well, that's good. Imagine what it feels like down here. Yes. What's making it bubble? Excellent question. Soapy water. Soapy water. Basically, if you do the dishes, that's the water. Except this is way more fun than doing the dishes. So, very good question. So rather than doing the dishes and getting bubbles made just of air, these bubbles just have methane through them. Just float up? Alright. Whee! I'm taking this little guy though. But that big one will float up, it'll pop a little bit, and then the remainder will go back down and the methane will escape out the roof. That's the great thing with methane. Because it floats up. It floats up and then it disappears essentially. Whereas other gases such as propane from my propane torch, it's not suggested to cook with propane inside the house because propane sinks. Propane has a molecular weight of 44.1. So it sinks. So if you have a gas leak, it's going to sink down to the floor, which is bad. Here, I'm going to build this one up, and then I'm going to turn it off, and I'll set the whole thing on fire. There we go. So that is a very, very neat thing with methane. Now, the last thing I want to show you is an experiment dealing with heat. So I said at the beginning that you don't need a spark, you just need heat. So this last demonstration talks about flash points. Now, flash point is the temperature at which something bursts into flame. For example, newspaper has a flash point of 219 degrees Celsius. So let's say you're unbelievably thin and you love really hot saunas, so you have it at 220 degrees Celsius. And you're reading the Globe or whatever you read, and you're flipping the pages, the dial reaches 220 degrees, you're sweating a little bit because you're thin, you're used to this. Boom! Your paper bursts into flames. You had no spark, you had no fire already, you just reached a temperature that caused it to catch on fire. That's the flash point. That's what this experiment's going to demonstrate here. So what I need is a bionic arm, an Erlenmeyer flask with some water, and a test tube full of a chemical that I'm not going to identify. Now, that chemical is in the same family as methane, propane, butane, octane, ane. They're alkanes. So, methane is a gas when it comes out because it only has one carbon. Propane, the liquid under compression when you release it, it's a gas as well. It has 3 carbons. Butane is in lighters. The liquid in lighters, it has 4 carbons, and now it's a liquid. Octane is the gasoline that you put in your car. It's also a liquid. Well, this guy has between 20 and 40 carbons. So it's very large. So large that it is solid at room temperature. So to get this guy to react, we need to melt it down. So I'm going to use the propane torch as a source of heat, but that's it. I'm not going to use it to light it on fire. And you'll see that in a second. So the first thing, as I said, I have to melt it down first. So melting it down, because it needs to be into a liquid. So there's a couple things at play right now. Firstly, it needs to reach its flash point, and then secondly, it has to have sufficient oxygen to ignite. So I'm going to melt it down for its flash point, but the oxygen is a problem, because right now with the test tube there's only a little bit of oxygen in the top, but that's about it, and that's not enough surface area. So what's going to happen is I'm going to take the test tube, and I'm going to drop it into the Erlenmeyer flask with water. Now what happens when a hot glass touches cold water? It shatters. Excellent. So it'll break, it'll shatter, the water will rush in. The water boils at 100 degrees Celsius. This is about 300 degrees Celsius. So the water's going to boil very rapidly and then push everything in front of it out of the way to get out of the test tube. And the stuff that's in the way is this stuff. So it's basically going to throw this stuff into the air. And what's going to happen? You're going to have a hot substance with oxygen in the air. So you'll have lots of surface area, a hot fuel, and it should burst into flames. Now, why do you think, right now, kind of an off-topic question, why do you think the blue flame is turning orange?
Cooling down.
Cooling down. Very good. The blue flame is hotter than orange flame, which is hotter than red flame. So if you look up at the stars in the sky and you think you're going crazy because you can see blue stars and red stars, you're not crazy, those exist. It's not supposed to go off yet. What happens is it boils to the point where it actually spilled out and it catches on fire. So it is very close. Alright, so we'll get it to go in 3, 2, 1. No fire, no fire, no fire. Fire. So, very important. It had no fire. I dropped it in. Fire appeared. That's very important. There was no spark. You kind of gave it away at the beginning where it kind of spilled over right in front of the flame. But when it got to this point, there was no spark. It was just heat. And that's a very, very important factor. So, if I take our test tube out here, the bottom is broken. As you can see. Now the bottom is broken. Let the water in. Launch the substance up into the air. Spread out, so you have surface area. It was at its flash point, it was at the right temperature, so it just burst into flames. And that's how our ancestors did it thousands of years ago. They didn't have sparks, they didn't have their little, well, they had sparks, but they didn't have their lighters, they didn't have matches or anything like that. They used flint, rock, wood. The flint, they would just make sparks. The wood, they'd rub together for 6 hours to generate enough heat to reach the flash point of the wood. So that's what they did. So you need heat, fuel, and oxygen. So there you have it. There's the fire show.